Assalamualaikum warahmatullahi wabarakatuh. So in this session, I would like to discuss beam with support settlement. This is flexibility method. Okay, we are going to do this together. Okay, so this is actually I take from past year's exam papers. Okay, this is the structure. Okay, this is indeterminate beam. If we look at to the support, we have here one one roller, one pin at A, roller at B, and pin at C. Okay, so let's look at the question. Okay, an overhanging ABCD as shown in the figure is pin supported at A and C and roller supported at B. The flexural rigidity of the beam as given. Okay, question number 1, draw the possible primary beams and their respective redundance. Okay, draw the possible primary beams and respective redundant. Okay, so kita go through all the question first. Okay, question B, using the flexibility method, calculate the reaction at all supports by taking into consideration the reaction at support C as the redundant. Okay, and then the last question, so this is the modification question because I want to analyze beam with support settlement. So I change question C. Okay, if support C is settled by 35 mm, calculate the vertical reaction at A. Okay, calculate vertical reaction at A. Okay, so to answer question number 1, question A, so let's look at the diagram. Okay, so in this beam, okay, A is pin, B is roller, and to remain stable and determinate, okay, the structure must have one pin, one roller. Means that we have to remove support at C. We have to remove support at C. Okay, so by considering there is no axial deformation as well as axial forces, we already know that AX and CX is equal to 0. Means that we can actually ignore CX as redundant. Basically, redundant in this case basically is 5. Okay, basically this one has 5 unknown reaction. It is 5 minus 3. Okay, is equal to 2. But because we already know that CX, it will be equal to 0. So we just can solve this. We just solve this by consider CY as the redundant. We remove CX and CY, but we already know that CY is equivalent to 0. So we just consider redundant as CY. Okay, so to answer question A, draw possible primary beams. Okay, draw possible primary beam means that we have to remain one pin, one roller. Means that, okay, to answer question A, what we should do is, so this is the answer for A question. Okay, so possible primary structure means that we have one is this, and this. Remain all external loading, remove one pin. So we get like this, one pin, one roller. So this will be the first possibility. Okay, for this possibility, we remove CX and CY. But when we remove CX and CY, we know that CX is equal to 0. So the redundant for this beam will be CY. cy. Okay, cy. We will analyze redundant cy applied. Okay, we don't need to analyze redundant cx applied because we already know that cx is equal to 0. Okay, this is answer number 1. Answer A. Okay, possibility number 1. Possibility number 1. Okay, we move to second possibility. Second possibility is when we remove A. When we remove A means roller here remain and pin at C also remain. Okay, so this is the triangular load. This is the moment. Okay, so having this, so this is the second possibility. This is the second possibility. So having this, we actually remove AY. We actually remove AY because again AX, we already know the value, and the value will be equal to 0. The value will be equal to 0. So we remove AY. So this is the answer for A. Okay, draw possible primary beams. Okay, and their respective redundant means that this one also we must draw. So means that we will have, okay, like this. Okay, pin at A, roller at B, roller at B. Okay, CY. So we have a unit value of CY. A unit value of CY. Okay, because we have to remain or ABCD, we have to remain the same. Okay, we have the same type of beam, just like primary beam, but we remove all external load. And we put a unit value of CY. Okay, same goes to the second possibility where we remove AX and AY, but the redundant system is a unit value of AY. So remain roller and pin at B and C. So we have to apply a unit value of AY. So this will be the answer. For question A. Okay, because this is the primary beam, and this will be the redundant beam. Okay, so this is the answer. Okay, let's look at the next question. Okay, using flexibility method, calculate the reaction at all support. By taking into consideration the reaction at support C as redundant. Means that we will choose possibility number 1. Okay, we will choose possibility number 1 to continue analysis. Okay, so what we need to do is, okay, we move to the second question. Okay, we move to B question. Okay, in B question, R is equal to CY. So we will get the compatibility equation. Compatibility equation is equal to delta C naught plus FCC times CY. This is equal to 0. Okay, basically we can write compatibility equation after we have chosen the redundant. Okay, CY. So means that we will solve CY using this. Okay, using this equation. This is the compatibility equation. Compatibility equation based on displacement at redundant position. Okay, displacement at redundant position. Displacement. Okay, at redundant position. This is also displacement at redundant position. But we have two system. two determinate system. One is primary beam. One is primary beam and another one is redundant CY applied. Okay, so primary beam and redundant CY applied is determinate beam. It must be stable. Okay, and we actually get the compatibility equation from what we call as principle of superposition. So from principle of superposition, okay, we know that in principle of superposition, it is actual beam equal to primary beam plus redundant CY. In this case, CY applied. So that is why we get these two. We get this and we get this. Okay, we have two determinate system to be analyzed. Okay, so since we need to calculate delta at C, okay, at both displacement at position C at both primary system and redundant system. So we need to have moment equation. We need to have moment equation. So in order to get that, we have to start with calculating reaction. Okay, so we start with primary system. Okay, in primary beam. Okay, in primary beam. Okay, in primary beam. Okay, we will get M naught. Okay, in primary beam, we will get M naught. So this is the beam. Okay, with pin at A, roller at B. So this is A, B, C, and D. Okay, this has triangular load and UDL. UDL, it is triangular load, not UDL, it is triangular load, and moment 310 clockwise. Okay, 310 clockwise, and 55. Length is 334. This is 55. Length is 334. So the length 334. Okay, this is the primary beam. So for this primary beam, we will calculate reaction at the support. So calculate reaction as usual. So taking moment at A is equal to 0. Okay, so we get here By. Okay, this is By. So it is 310 positive. Okay, plus moment. Okay, the triangular load, the area is force. The area 1/2 times 4 times 55. Okay, and the centroid is somewhere here. The centroid. Okay, So it is 2/3, yeah. So it is 2/3. Okay, 2/3 times 4. Okay, plus 6. Okay, plus 6. 2/3. It's 2/3. Okay, it is also plus minus by times 3. Minus by times 3. This is equal to 0. So we get by. We get by is equal to, okay, we solve this. Okay, we solve this. Okay, it is 2/3, 2/3. Okay, 2/3 times 4. Okay, plus 6 times 55 times 4 divided by 2 plus 310. Okay, divide by 3. So we get 4 to 1.11 kilo Newton. So this is the BY value. BY value. So after this, we have to calculate AY. We have to calculate AY. So this is AY. Okay, this is AY. So we apply Fy is equal to 0. Total Fy is equal to 0. So we get AY. We get AY plus BY minus, okay, the area of triangular, 1/2. It is 55 and 4. And this is equal to 0. This is equal to 0. So it is AY equal to 55 times 4 divided by 2. We 55 divided by 2. We minus by 4 to 1.11. So what we get is negative 311.11 kilo Newton. 311.11 kilo Newton for AY. Okay, so this is BY, this is AY. BY and AY. Okay, so means that we will analyze this beam. We will analyze this beam. Okay, so I will transfer all the value. BY, AY is negative 311.11. BY is positive 411.11. And then there is moment clockwise 310. And then triangular load, okay, of 55 kilonewton per meter. 55. Okay, it is 55. 55. Okay, so this is A, B, C, and D. A, B, C, and D. Means that we will analyze this beam. Okay, we will analyze this beam to write moment equation. To write moment equation. To write moment equation. Okay, so the moment equation, M naught. This is primary beam. This is M naught. So we have three cutting section. We have AB, one section, BC, another one section, and CD, another one section. And by looking at this diagram, so we cannot analyze. We cannot take origin at D. We cannot take D as origin. Okay, whenever we want to cut section CD, because when we choose D as origin, we have trapezium. Okay, we have trapezium. And normally what we analyze is triangular, because we know the centroid is one third and two third, and we do not know the centroid for trapezium. So we have to choose origin from left. Okay, so we have to analyze. Okay, section number 1. Okay, it is section number 1. For section number 1, it is AB. Okay, origin is A. Okay, limit is 3 meter. So it is X is between 0 to 3 meter. Okay, the section is this one. This is 311.11. So the moment is anti-clockwise. So this is M naught. This is M naught, and distance is X. This distance is X. Okay, X. So what we get is, okay, taking moment at the cutting point is equal to 0. Okay, so what we get is negative M naught, negative 311.11 X. So we get M naught is equal to negative 311.11. Okay, 311.11 X. Okay. Okay, this will be the first section. Okay, now we move to second section. For the second section, okay, what we have is, okay, we draw the cutting section, the diagram. We draw the diagram. We have 311.11, and we have 421. Okay, let me check back. Okay, 421.11. Okay, it is 421. Here is 421.11. There is moment 310. So we have A, B. Okay, so we cut section at this point. We cut section at okay, so this is the cutting section. Okay, A, B, B, C. and moment. This is m naught. This is m naught. Okay. So for this one, this one, this is section number 2. This is section number 2. Okay, and section number 2. Okay, this is section number 2. This is BC. Okay, BC origin. BC origin, I want to choose B as origin. Okay, always remember that every joint can be origin. Anyone can be origin. Anyone can be origin. Okay, not necessary A always be the origin. B also can be origin. A also can be origin. So the limit will be depend on the origin. Okay. So for this, okay, this is BC. Okay, this one is BC, section number 2, BC. Section number 2, BC. I want to choose B as origin. Okay, section number 2. For section number 2, this is BC. Okay, I want to choose B as origin. Origin B. Origin B. Origin means where X start. Okay, it means that, okay, this is, if origin is B, means that X start from B. This is X. Okay, means that here is 0. Okay, this 0, this is 3 meter. 3 meter. So means that 0, 0 to 0 to 0 to 3. Okay. So the distance, the L, the X, okay, the X is between 0 to 3 meter. BC origin B. BC origin B, because origin means dekat mana X to start. At origin, X is equal to 0. And what we want is the equation that is only for BC. So we get this. Okay, from this we write the equation. Okay, by taking moment at the cutting point is equal to 0. So it is negative m naught. Negative m naught, we have a plus 310. Okay, we get negative 311.11 times, okay, this distance is 3 plus x. So it is 3 plus x. Okay, and then we plus with 421.11 times x equal to 0. Okay, so m naught is equal to, okay, what we get? Okay, 311, it is 310 minus 311.11 times 3 times 3 times 3. So we get negative 623.33. Negative 623.33. And then what we get? We get 421.11 minus 311.11. So we get plus 110x. Okay, so this is the equation, the moment equation. the moment equation for section number 2. And now for section number 3, what we have is, okay, because we cannot take from D. Because D, when we take D, okay, we will have trapezium. We cannot have that. So that is why we have to again consider from right. So from right we have 311.11, 421.11, 310, and then we get this. Okay, so we have A, B, C. Okay, A, B, C. So let's say for this one, again I want to take okay, this is cutting section number 3. For cutting section number 3, this is for CD. I want to choose C as origin. So by choosing C as origin, okay, X is 0 to 4. Means distance of CD, 4 meter. And then okay, means that origin C means X is, okay, located at C. Okay, start at C. Means that at C, X is equal to 0. So the distance, okay, this is 3, this is X. Okay, so we have to write moment equation. Okay, by taking moment at the cutting point. By taking moment at the cutting point, so what we have is, okay, write the equation. It is negative m naught plus 310, okay, a minus 311.11, 6 plus x, and then we have to plus 4 to 1, okay, 3 plus x, 4 to 1 is 3 plus x, okay, 3 plus x, 4 to 1, and we have to, okay, minus, okay, before that we have to actually identify, we need to actually identify, okay, what is this value? We have to identify. So using interpolation, this is 55. This is 4 meter. Okay, so if this is x, so what is this value in terms of x? So we have to interpolate. Okay, so what we want is, so 4 is equivalent to x. It is 4 is equivalent to x. So 55 is equivalent to, okay, this is called as interpolation. Okay, 55x divided by 4. So this one we get 55 divided by 4. We get 13.75x. So the value here is 13.75x. So the area is 1/2, okay, x, and 13.75x. Okay, times with this the distance from centroid. From centroid we use 1/3, okay, times with x, and this is equal to 0. This is equal to 0. So we solve this. We solve this. We get m naught. We get m naught. We get m naught. So it is 310. It is 310. We minus by 311.11 times 6. And then we plus by 421.11 plus 421.11 times 3 okay, so we get negative 293.33 293.33. Okay, for x value we get negative 311.11 plus 421.11. Okay, 110 again, plus 110x, and we have another one. It is 0.5 times 13.75 times not times, divide by 3. So we get 2 point, it is minus 2.292 x cube. Okay, x cube. So this will be the moment equation for cutting section number 3. Cutting section number 3. Okay, for cutting section number 3. Okay, so only after this we can move to the redundant system. Okay, to the redundant system. Now we move to redundant. Okay, redundant beam. This will be more easier. Okay, this will be more easier. This is MC. Okay, redundant CY applied MC. So beam. Okay, beam, a unit value. Okay, we have here AY, here BY, and then we have a unit value. A unit value of CY. A unit value of CY. So we have to calculate the reaction. Okay, calculate reaction. Of course, here is AX. And we already know that AX is equal to 0. Okay, so we analyze this. So this is 3 meter, and 4 meter. So taking moment at A is equal to 0. So we get a negative BY times 3 minus 1 times 6 is equal to 0. So we get BY equal to 0. It is 6 divided by 3. It is 6 divided by 3 equal to 2. So we get 2. Okay, it is 6 divided by 3. 6 divided by 3. Okay, so the value is 2, negative 2. So if this is negative 2, for Fy is equal to 0, we will get negative 2. So it is Ay plus By plus 1 is equal to 0. So Ay minus 2 plus 1. So we get Ay equal to 1. Okay, equal to 1. So in order to write the moment equation, okay, I draw another one. So I put all the value. So Ay is 1. By is negative 2. Okay, see a unit value. Here is a unit value. So this is A, B, C, D, 3 meter, 3 meter, 4 meter. And now we will write the moment equation. Okay, we will write the moment equation. So the moment equation. Okay, this is MC. Okay, moment equation MC. Okay, because why we need to have MC, because we have to refer to delta 1 naught, delta C naught at position C. Okay, plus FCC times CY. Of course, you can also write delta 1 naught plus F11 times CY. Doesn't matter. Okay, both are same. Okay, moment equation, we start with section number 1. Section number 1 will be simple. Okay, section number 1 will be simple like this. This is M1, MC. Okay, we use this the same. Okay, we use MC. If you want to use M1 also okay, but we must be consistent. Okay, MC. So this one, what we get is negative MC plus 1 times X equal to 0. So MC is equal to 1. Sorry, X is equal to X. Okay, we move to section number 2. Section number 2. Okay, for section number 2, what we have is this is 1, this is 2. Okay, MC or M1. Okay, so distance, this is 3, this is X, because we need to refer back to the same. Okay, the same origin. Okay, the same limit. Okay, what we have here is negative MC, negative MC. It is negative MC plus 1, 3 plus X. Okay, minus 2 times X equal to 0. So MC will be equal to, okay, it is 3. It is 3 and minus X. 2, it is minus 2 plus 1. Minus 2 plus 1 is 3 minus X. So this is second section, for the second section. Okay, for the third section, okay, we have 1, 2 here, 1 here. Okay, this is MC. Okay, so origin at C. Origin at C, so this is 3, this is 3, this is X. Okay, so for the cutting section, it is negative MC plus 1 times 6 plus X minus 2, 3 plus X plus 1 X equal to 0. So we get MC equal to, okay, it is 6 minus 6. 6 minus 6 plus 6 minus 6. Okay, and then X, okay, it is X minus 2X plus X. Okay, X. So what we get? We get 0. We get 0. It is 1X minus 2X plus X. So we get 0. Okay, we get this is equal to 0. Okay, so we get this equal to 0. Okay, so this is the equation. Okay, so now we have to calculate delta 1 naught. Sorry, delta. Okay, depending on the label that we use. If you use C naught, so just use C naught. If you use 1 naught, just use 1 naught. Don't mix. Okay, don't mix. Okay, it is delta C naught. It is delta C naught, which is equal to 1 over EI. 1 over EI. Okay, let's look at back the question. Okay, EI is constant. EI is constant. Okay. The formula is MC M naught dx from 0 to L. So here, okay, this is when we want to write equation directly into the displacement formula without having table. Okay, so it is 1 over EI. Section AB is from 0 to 3. Section AB is from 0 to 3. Okay, section number 1. Okay, MC for section number 1 is X. Okay, is X. And we have to times with, okay, M naught for primary system. M naught for primary system is M naught for primary system is okay, wait for a while. Okay. Okay, M naught for primary system is this. Okay, it is 311.11x, negative 311.11x. This is for section number 1. 311.11x. Okay, it is 311.11. It is negative x dx. So this is for section number 1. Section number 1. Okay, we have to plus with section number 2. Section number 2, again 1 over EI. From 0 to 3 again. From 0 to 3 again. So it is MC. MC is 3 minus x. MC is 3 minus x. Okay, it is 3 minus x. 3 minus x. We times with okay, the moment equation for section number 2, the primary, in the primary system. In the primary, we have negative 623.33 plus 110x, 110x, negative 623.33. Okay, it is negative 623.33. It is negative 623.33 plus 110x, okay, dx. And we have to plus with the second, the third section. And the third section, since this is equivalent to 0, okay, this is equivalent to 0, so actually we just need to consider these two, okay, these two. So we have to integrate this. We have to integrate this using calculator directly, okay, and give the answer in terms of EI. In terms of EI. So we use calculator to calculate this, to integrate this. Okay, use calculator, use your calculator to integrate this. We'll integrate. So we integrate x. It is x. Okay, times 311 negative 11 x, limit from 0 to 3. Okay, so the first value is negative 2799.99 over EI. Okay, and we integrate another one. It is 3 minus x times negative 6 to 3.33 plus 110 x, limit from 0 to 3. Okay, it is negative 2309.985 over EI. So this is equal to, we minus back with 2799.99. So we get negative 509.975 over EI. Over EI. It means that we actually don't need to calculate to write the moment equation for section C, because moment at C is equal to 0, moment equation. Okay, so now we will calculate F11 or FCC. Okay, use the same if you use C, all C. If you use one, all one. So this one FCC. Okay, FCC. So this is equal to 1 over EI from 0 to L MC squared dx. MC squared dx. So it is 1 over EI from 0 to 3. So it is x squared dx plus 1 over EI from 0 to 3. Okay, it is 3 minus x. 3 minus x square dx. So the answer for this is, it is square from 0 to 3. We get 9. And another one is 3 minus x square from 0 to 3. It is also 9. So we get 18 over EI. So we substitute into compatibility equation. So we get compatibility equation. Okay, we use this CY symbol as this, and we substitute the value. Okay, negative 5109. 5109. Negative 5109.975. Okay, over EI plus 18 over EI CY equal to 0. So we solve this solving compatibility equation. Solving compatibility equation, we get CY is equal to 5109.975 divided by 18. And this is equal to 5109.975 divided by 18. This is 283.9 kilonewton. Okay, this is the CY value, CY. So now, after having this redundant, we can be able to continue to calculate AY. Okay, to calculate AY. Okay, AY and BY we can calculate using principle of superposition. Using principle of superposition, we have to look back to the reaction in primary system and in redundant system. In primary system, okay, AY is 1. In redundant system, in primary system, it is 311.11 negative. Negative 311.11. Okay, negative 311.11 plus 1 times 283.9. Okay, and BY is 421.11. Okay, minus 2 times 283.9. Okay, means that this is come from primary system, because we are referring to the same principle of superposition. The other way to calculate reaction, okay, for this we can also consider we can also use principle of superposition beside calculate the remaining reaction using equilibrium equation. Okay, primary system, and this is the BY which come from redundant system. So what we get is negative 311.11 plus 283.9. So we get negative 27.21. Negative 27.21. Negative. It is negative. And then, okay, 4 to 1.11 minus 2 times 283.9. We get negative 146.69. 146.69. Okay, so this is in kilonewton, this is in kilonewton. Okay, so we settle question B. Okay, question C, we need to consider support settlement. Question C, we need to consider support settlement. C. Okay, support settlement means, okay, delta in actual system is not equal to 0. Delta in actual system at position C is equal to 35 mm. And it is downward because deflection, okay, in downward direction. Negative 35 mm is equal to negative 0.035 meter. So what we need to do is very simple. It's very simple. We have to have new compatibility equation. New compatibility equation. Okay? New compatibility equation, which is not equal to 0 anymore. It is equal to the settlement value, settlement given. It is delta C naught plus FCC times CY equal to negative 0.035. So what we need to do is we just need to, okay, have this again. Okay, the compatibility equation. The compatibility equation, this is the equation. Okay, this equation, we have to 5109.975. It is 5109.975. It is negative over EI plus 18 over EI CY, okay, equal to negative 0.035. Okay, and given in the question EI value, so we have to substitute EI value into this. EI is 100,000. So it is 5109.975 divided by 100,000. So we get 0.05, 0, negative 0.0, 0510, 511. Okay, plus with, it is 18 divided by 100,000. So we get 0.00018 CY equal to negative 0.035. Okay, solve this. We get CY. We get new value of CY. It is negative 0.035 plus 0.051. Okay, 5109. 5109. Okay, we divide by 0.00018. So CY we get negative. It is negative 0.035 plus 0.05109. Okay, 5109.995, 51, actually 511. Okay, divide by, okay, we divide by 0.00018. So we get 89.4. 89.4 kilonewton. So what we get is the new value of redundant by only replace the displacement, the displacement in actual system from 0 to the displacement value, and then we solve again the compatibility equation, and we get the new value of redundant. And to continue to calculate AY, okay, to calculate AY, it is negative 311.11, okay, 311.11 plus 1 times 89.4, okay, this is equal to negative 311.11 plus 89.4. So we get negative 221.71 kilonewton. Okay, and this is the reaction at A after settlement. After settlement. Okay, so without settlement, what we get? Without settlement, we get, okay, without settlement, we get negative 27.21. Okay, after settlement, we get the value equal to positive 89.4. Okay, no. 89.4 is redundant. AY after settlement, okay, it become negative 221.71. 0.71. So we can compare these two value and we can conclude. Okay, we can conclude why is it happen. Okay, so that is all the solution for the question given, okay, in the beginning of this video. So this is actually how we analyze analyze beam, analyze structures, indeterminate structures using flexibility method. Most important thing is the basic of writing moment equation. That is very, very important. Okay, without moment equation, we cannot calculate displacement. That is why you have to practice to write the moment equation. Okay, so thank you very much. Thank you for this session. So we will meet again in the next session to discuss another maybe another type of structure. Okay, we will meet again till we meet again. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh.